Hello, good evening, Amit.
Hello.
Yeah, good evening, Amit. How are you?
Yeah. Good evening, Varun. How are you? I'm fine.
Yeah, I'm fine. Even I am fine.
Okay. So let's wait for another 2-3 minutes. After that, we will
Okay.
start.
Okay, sure.
So, good evening, everyone. I welcome you all to the live session number 9 for NPTEL course Energy Conservation and Waste Heat Recovery. So, I am Amit Kumar Sharma, course chair for this course. So, as you know, every week on Friday from 7 to 9 p.m., uh, there is a live session. So, in this live session, we discuss about the previous week's course content and some sample assignment problems. So these are very helpful to you in your upcoming assignments. So I hope you join the session and you will learn more about how to solve the problems and how to apply the concept in the problems. Okay, let's start with the today's class. Question number 1 is COP of a heat pump is always. So we have to tell that COP of a heat pump is always like equal to 1, less than 1, greater than 1, or none of the above. So take 2 minutes to answer. Try to recall the relation between the COP of heat pump and COP of the refrigerator. Maybe from that you will get the answer. Try to recall that.
It's greater than one.
Okay, so we have one answer that COP of heat pump is greater than 1. Let's wait for another 1 minute. Anybody else want to answer? So today also we are having only one participant, is Varun. Okay. But still we want to wait for 1 more minute because maybe the students are not able to join the live session due to their maybe the work, maybe the personal issues. Maybe they are uh, taking these classes online, so they can also use this 1 minute to solve. Okay, so the answer is C. COP of heat pump is greater than 1, and there is a very important relation, that is that COP of heat pump is always greater than 1, and it is 1 plus COP of refrigerator. It is a very important relation. So for given conditions, if the same system is like working like a refrigerator and heat pump, so this will be the relation. COP of heat pump will be always will be 1 plus COP of refrigerator. Okay, so this is a very important relation. If you are having a COP of heat pump, you can also find COP of refrigerator with the same conditions. Question number 2. The size of a heat pump depends on. So you have to identify that what are the main parameters on which the size of heat pump depends. So the options are: option A is air volume and air charge requirement, B cooling load, C heating requirement, and D all of the above. So try to think like every aspect and try to come up with reasoning also.
Yeah, it's option D.
Option D. So Varun, what are the reasoning? Please explain.
So if I go to option C first,
Okay.
so heating requirement. So
Okay.
obviously, if you are having more heating requirement, so the size of the heat pump will be more.
Yeah.
Second thing, cooling load. So cooling load in the sense, if you are using the same heat pump as a refrigerator by using that modulator switch or something, so automatically the cooling load will be more. If you want to cool the
Okay.
room more, so automatically the cooling load should be high. And air volume
Yeah.
and air change requirement, it's like if your space which you are cooling or heating is high, so the more it's like more volume of air will be there, so more heat is required to heat that space. First thing, and second thing is air change requirement. So it's like the heat transfer per, it's like the energy per second which you are removing, or this happens, right? So more heat change for requirement means more heat transfer should be there. So in that way,
Yeah.
air change requirement also it matters.
Yeah. Correct. Correct. So the correct answer is option D, because we know that the size, basically the size. So the size of heat pump. So basically the size will depend on the, like, what is the size of your requirement, you can say, like heating requirement, cooling requirement. And if heating requirement is more, it means that we have to flow more air also. The room is also big, so the air volume and air charge requirement will also increase. So based on that, the size of heat pump will depend on the air volume and air charge requirement, on cooling load and heating requirement. So these are, you can say, self-explanatory. Okay. So the size of heat pump depends on all of the above. The correct answer is option D. Number 3. Templifier is a space type heat pump and uses space compressors for its operation. So we have to identify which type of a templifier is which type of heat pump is it and which type of compressor it uses. Option A, air 1, liquid water 2, water 2, liquid water 1. Try to remember, try to think about it. Take 2 minutes to answer it.
It is option C, water, and two compressors are used.
Okay, let's see. Okay, so let's see the answer. So basically, a templifier is a water type of heat pump. Okay, so it uses two compressors. One is low pressure and one is high pressure compressor for its operation. So the correct answer is option C. Templifier we use to recover the maximum heat. Okay, so it is a water type heat pump and uses two compressors. One is low pressure and the other is high pressure compressor for its operation. So number 4. For an air heat pump used for year-round air conditioning, what is the function of four-way valve? So try to remember about four-way valve. So what's the main function of this? Option A enables use for the same working fluid both in winter and summer, reverse the functioning of evaporator and condenser, reduce irreversibilities, improve COP of the heat pump. Try to remember about the class discussion or notes. Let me know the answer. So first of all, the hint is the year-round air conditioning. So year-round there will be winter and there will be summer. Okay, try to remember this. Also draw a basic diagram. So here, suppose 1 is the evaporator, 2 is the condenser, and 3 is the four-way valve. So diagram, this is a basic schematic, okay? For the more detailed diagram, you can refer to the class notes. This diagram is just for the explanation of this question. Now I think you can remember, if we want year-round air conditioning. So in winter, we need heating. In summer, we need cooling. Okay, in winter, we need heating. So what is the main purpose of evaporator? Yeah, Varun, any idea? Like evaporator, what does evaporator do?
Evaporator, it it absorbs the heat from the circulating fluid and it vaporizes, and it
Okay.
vaporizes the fluid in it,
What will be the
the
effect of
refrigerant.
evaporator on the ambient, like on your control volume? Will it heat or will it cool?
It cools.
It cools, yeah. So evaporator basically do cooling,
Cooling effect,
and the condenser is doing
heating effect.
heating effect. Okay. So what is the answer, Varun, then?
It's option B.
Option B. Okay. So the correct answer is, let's see, option B, because it do the reverse the functioning of evaporator and condenser. Okay. So in winter, we need heating. So this four-way valve like act that this condenser will be do heating, and the effect of this side will come into our room. Okay. On the opposite side, uh, in summer, we need cooling. Then this four-way valve will change the operation. So now this condenser will work as evaporator. Okay. And this will work as a condenser. So they will be interchanged. Okay. In the working principle. So the four-way switch changes the route of refrigerant so that the indoor heat exchanger function as evaporator in summer and condenser in winter. Point to be noted. The indoor heat exchanger function as evaporator in summer and the condenser in the winter for the refrigeration cycle. Similarly, the outdoor heat exchanger becomes the condenser in summer and evaporator in the winter. So basically, four-way valve is changing the operation of evaporator and condenser. So basically, it reverses the functioning of evaporator and condenser. So the correct answer is B. The option C is wrong because it doesn't reduce irreversibilities. The irreversibilities will remain same. Okay, because we are not changing the evaporator and condenser. We are just changing the function. We are changing the, you can say, the direction of the working fluid. It improves the COP of heat pumps. Option C is wrong. Option D improves COP of the heat pump. So we are not doing any mechanical change. Okay. So there will be any, and we are also not doing any any change that can affect the COP. So it will not be the case. So option D is also wrong. Option A, it enables use of the same working fluid both in winter and summer. So that is all the working fluid will remain always same. So we are not talking about it will not do with the working fluid. We have to reverse the functioning. Okay. Option A is also wrong. So the correct option is option B. Option number 5. For drying application, the most warm air is passed through the evaporator tube. Option A, reduce the temperature of warm air, condense the water vapor and remove it from moist air, upgrade the quality of air, and D, all of the above. Take 2 minutes to answer.
It's option A and B.
Okay. So what is the reasoning?
So it's like for drying application, you always you need first of all dry air should be required. So if you pass the moist warm air into the evaporator, due to the
Okay.
cooling effect, the water vapor in the moist warm air condenses, and you will be left with dry air. First thing.
Okay.
And second thing is that due to the cooling effect only, even the temperature decreases due to reduce of this sensible heat also. So later on, if you are passing the same air into the condenser section, so due to the release of heat, due to heating effect, it gets hot again. So that air again sent to the timber or some drying application. So this cycle repeats again. Again there again air becomes moist and warm.
Yeah. Yeah. So basically, this drying application is, you can say, the timber drying. Okay. So the correct answer are A and B. So evaporator decreases the temperature of the air below dew point to condense the water vapor, which is further removed from the moist air to make the air dry. Okay. So basically, the evaporator, what the most air is passed through the evaporator to reduce the temperature of warm air. So it will reduce the temperature of warm air, and it will condense the water vapor and remove it from the moist air. So this moist air will become the dry air, and this air will be used for the drying of timber. Okay. Then again, this dry air will observe the moisture from the timber, and again it will go to the evaporator. And in evaporator again, it will reduce the temperature of the warm air and condense the water vapor and remove it from the moist air. So the answer are A and B. Option C is wrong because there is no such case of upgrade the quality of air. Like so, like we are not purifying the air. Basically, just we are removing the moisture from the air. Okay, we are not upgrading the quality. Option C. Question number C. Question number 6. Incinerators are categorized according to. Okay, so we have seen incinerators in our class. So they are categorized according to the option A, state of the waste that is being incinerated, amount of energy that is resulted out of the incineration, C, the process heating, and D, all of the above. Try to think about it.
So option A, state of waste that is being incinerated.
Okay, just wait for one more minute. After that, we will discuss it. Okay, so the correct answer is option A. So what is the reasoning, Varun?
It's like, as we know that incinerators are categorized in three ways. One is solid waste, liquid waste, and gaseous waste in incinerators.
Okay,
So in that way, we can say that it is state of waste heat, that is waste that is being incinerated.
yeah, correct. So basically, as Varun said, they are categorized according to the state of the waste, like liquid, solid, and gaseous waste. Okay, so the option A is correct. Option B, amount of energy that is resulted out of incineration. So no, they are not categorized according to this, because if we are handling liquid, if we are handling solid, then we have to design according to that. So based on that, they are categorized. The process heating, no. So option B and C are wrong. So the correct option is option A, the state of the waste that is being incinerated. Number 7. In the fume incinerator discussed in class, which is the gas that is used for polyester synthesis? So try to remember the class notes and tell me the gas which is used that is used for polyester synthesis. Take just 1 minute to answer it. Any idea, Varun?
So it's malic anhydride.
Okay. So let's see the answer. So the answer is C. It's N-butane.
But okay, but in class notes it is said that it's Tyler of fume gas, which is known as malic anhydride, and it occurs due to the oxidation of N-butane. Okay,
Okay.
might be the main source gas they were asking, might be that N-butane.
Maybe, yeah. They are asking for the gas that is used for polyester synthesis. So that is the main, like, polyester synthesis. So we are using N-butane. So in detail, you have to refer the class notes. But
Okay,
if you
sure.
are going for the polyester synthesis, require N-butane.
And
Maybe there will be other gases also, but maybe they are not used for the polyester synthesis, because you are doing incineration, then there will be number of gases. But we have to purify that gases, and the N-butane can be used for the polyester synthesis. Number 8. So there is a heat pump using R12 for winter space heating of a residence. Okay. The building heat loss is 25 kilowatt. Compression is reversible and adiabatic. Inside temperature of the building 30 degree. Ambient 15 degree. Determine the COP of heat pump. So we have given the data. I have also underlined the important data from this. Let me know the COP of heat pump. Take 2-3 minutes. Very important numerical. Maybe similar numerical will be in your current assignment or will be in your upcoming exam. Any answer, Varun?
It's 20.2 COP.
Let's wait for 1 more minute. So, for a hint, so we have given the inside temperature is 30 degree. So it's 30 degrees centigrade. And ambient, suppose it's ambient 15 degrees centigrade. Okay. So winter space heating of residence, the building heat loss is 25 kilowatts. Compression is reversible and adiabatic. Inside temperature of the building is 30 degree, ambient is 15 degree. Okay. So we are doing winter space heating. So we are doing heating. So this will be our QH will be our, you can say the desired temperature, 30 degree. It's QC. So we are providing some work input to the compressor, WC. So COP is desired effect upon work input. So desired effect here is QH. Work input is WC. We have given the reversible adiabatic compression. So if reversible is given, okay, we are not having WC. Okay, the heat loss 25 kilowatt is given, so QH can be taken as 25 kilowatt, but we are not having WC. But we have given reversible and adiabatic, so we'll use temperature. So first of all, convert this degree centigrade into Kelvin. So this 30 will be 273 Kelvin plus 30. Okay, will be 303 Kelvin. And this will be 273 plus 30. 3. Okay, it's not 30, it's 15 only. Sorry. It's 15. 8, 8, and 2, 288. 288 Kelvin. So COP will be the desired temperature 303 upon difference between the temperatures. 303 minus 288 will be how much, Varun?
20.2.
It will come to 20.2. So this is your answer D. So the correct
Yes.
answer will be
So, Mr. Amit, I have a small doubt here. It's like,
yeah.
so my doubt is that, so generally, if we say that any cycle is reversible, so each process should be reversible process, right? Generally, okay, to complete a cycle, if we want to say that a cycle is reversible cycle or we are getting a maximum COP or efficiency, so every process should be a reversible process. But here they are telling that the compression is only a reversible adiabatic. We don't know whether the heat transfer is reversible heat transfer or something like that, right? So that's actually okay. It's like I have calculated this because there is no any option for me to calculate the compressor work. So I have taken the COP directly equivalent to the Carnot efficiency and I have calculated with the help of the temperatures. So
Yeah,
directly
yeah,
I
yeah.
got the answer. But while doing the solution, I have a doubt. So this is my doubt. Why? Because if they say that the what is the maximum COP or what is the minimum work done? Okay, in that way, again, it might be a reversal. If they ask minimum work done means we have to calculate the COP efficiency, COP of the Carnot generally, right?
Yeah, yeah.
So this is
Basically,
my doubt.
yeah, I think you want to say that like compressor is reversible. Okay, fine. What about this heat transfer?
Yes.
Yeah, okay. So, I think they should mention. I think that it will be reversible. Like complete process should be reversible. But I think normally if they mention like this also, compression is reversible and adiabatic. So they are considering both the input to the compression also and output to the compression also. Because if compression is reversible, then suppose if you say if this compression is reversible, so it will be reversible only when the input and output are also reversible. Suppose you are saying that this, or let me just clear it. It's a very genuine doubt. Good question. Let's just discuss it. So there is suppose compression, okay? This is a compressor. And okay. Maybe this is 10 kilowatt, maybe. This is 15 kilowatt, okay. So we are saying that compression is reversible. So this is reversible, okay. The diagram is very bad. Okay, so it's reversible. Okay, so just let me tell one thing. This compressor is reversible. Okay, so it means that there is no irreversibilities. Okay, so the input, the both other limits are fixed. Okay, there are no, you can say the these are limits are fixed. So this is T1 and this is T2. So both T1, T2 are fixed temperatures. Okay, we have already fixed the conditions, and we have given the compression is reversible and adiabatic. Okay, so what is your doubt? Your doubt is that this process, is it reversible or not? Am I right?
Yes, yes.
Yeah, okay. So just tell me one thing, that you have given three conditions. First, the compressor is reversible. Second, you have given T2, and third, you have given T3 also. Just suppose if we are going in forward direction, then this is 5 kilowatt, okay, and this is 10 kilowatt. If this process is not reversible, this 5 kilowatt is not reversible, suppose, then this 5 kilowatt will reduce because this T2 is already fixed. This T2 is fixed. So this 5 kilowatt will reduce. Am I correct?
Yes, yes.
Yeah. Maybe this will be 3. If this will change, but compressor is reversible, it is doing the same amount of like consuming same amount of work, or like the condition will be same for this. But this will also change then. This 10 kilowatt will also change because this 3 has been changed. So this will also change. But now what about this condition number 3? So if you are
Where
saying
the
that,
temperature is fixed again there.
yeah, so we have 3 boundaries because we have T2 given, T1 given, and the compressor given. Then to meet all 3 boundaries, your this heat transfer should be reversible. Otherwise, you cannot achieve all the boundaries, and you will violate the conditions given in the question. Is it clear?
Yeah, as you said, we will be saying, right? Okay, the process to be reversible, we should have it's like the temperature, heat transfer should be occurring at a constant temperature. Like,
Yeah,
okay, that thing. So in that case, the two things will be valid. And one more thing, even at the same time, while I'm expressing doubt, even I got an idea. Generally, while they're questioning it, they'll be saying that, so what is the minimum work to be done by the compressor? So at that time, we will automatically take the Carnot efficiency, Carnot COP, and we'll be
yeah,
directly substituting the temperature limits, and we'll be getting the compressor work. So they'll be
yeah.
not mentioning that, okay, you take these, the heat transfer is also
Also
reversible, nothing like
reversible
that.
because we have given other conditions. So for those conditions to be true, your this heat transfer should be adiabatic and reversible.
Yes, now it's fine. It's a good thing. Yeah.
Yeah.
Thank
Okay.
you.
Okay. Thank you. Okay, I think it was a very good doubt. I think it will be very helpful to the online viewers also. Okay, let's come to the next question. Question number 9. For the above heat pump, like previous question number 8, what is the work done by the compressor? So in previous question, let me show you just for 2-3 seconds. Take the data. Let me know the work done. Okay, let me know the work done. Let me again show you the question. This is the question. So in this question, the same question is that now find out the work done.
So the answer is 1.23 kilowatt.
Okay, let's see the options. Okay.
Yes, sir. Option A is correct answer.
Oh, nice. We have another student. Sehbaz. Okay, Sehbaz is there. Hi,
Yes, sir.
Sehbaz. How are you?
Fine, sir.
Okay. Good.
TOP is equal to work done by.
Yeah. So let's see the answer. So we know that COP is desired effect on work done. Okay. So the desired effect is because in this question we can see the building heat loss is 25 kilowatt. So building is losing heat at 25 kilowatt. So we have to like compensate this loss. So the desired effect will be is 25 kilowatt. COP will be 25 upon this work done, and we have already calculated the COP as 20.2. So COP will be 20.2 equals to 25 upon work done. So work done will be 25 upon 20.2. It will come to 1.237 kilowatt. Okay. So the correct answer is option A. Okay. Okay. COP will be 1.237 kilowatt. Question number 10. Which of the following is a type of mechanical storage system? So basically it's a mechanical, you can say mechanical energy storage systems. Options are option A, pumped hydroelectric system, B, batteries, C, compressed air energy storage, and D, all of the above. Take 2 minutes. Let me know the answer with reasonings. Any answer?
It's option A and C.
Okay. And what are the reasonings?
It's like hydro, it's mechanical energy storage system. So we can get pumped hydroelectric system where you can store the water at a greater potential energy, and that potential energy again can be converted into the mechanical energy where you can in turn generate electricity again.
Okay.
So that is one thing. And compressed air energy storage system, I feel like suppose you are using the excess energy to compress the air first, and again later on you can expand that air
Okay.
in a turbine, and again you can generate the electricity. It's like you're converting, giving the energy to compressor, again pulling it out using the turbine.
Okay. Any other answer? Shahbaz?
Yes, sir. Option A and C are correct, sir.
Option A and C. Okay,
Yes.
let's see the answer. So correct. Option A and C are correct. So in mechanical energy storage system, the energy is stored in mechanical form, such as the pumped hydroelectric system. Okay. So this is the example of this schematic is showing the pumped hydroelectric system. Okay. So because in this, like suppose there is less demand. Okay. So what we will do? We will pump back this water to again to a higher level, so that we will gain a potential energy, and in the case of high demand we can generate more power. So basically we are storing the energy. Similarly, in compressed air energy storage system, if we are having excess power, and what we will do, and the demand is less, so using that excess power we will compress the air. Okay, we will compress the air and store that energy in the compressed air. So the compressed air will be have very high temperature, high pressure, and after some time, when we require the energy, so we can use that energy to generate steam, because the compressed air will be at very high temperature, and we can run turbine also. The compressed air will be at very high pressure, so we can also use the pressure difference to generate energy. Okay, in this way we can store energy in mechanical form. The option B is wrong, because batteries are totally depends on chemical. Okay, so they are basically electrochemical devices. So there is no form of mechanical energy linked to the batteries. So batteries are wrong. Option A and C are correct. Okay, question number 1. What is the desired effect in a heat pump system? There are 4 options. Like, what is the desired effect? Reduction in energy cost, the external work, heat rejected at higher temperature, heat extracted at lower temperature. Take 1-2 minutes. Let me know the answer, and let me know also the reasoning. Try to also remember the formula of COP. The formula for COP is desired effect upon work input. So what is the desired effect in that formula?
It's option C, heat rejected at higher temperature.
Okay. Any other option? What is the desired effect in heat pump system? Shehbaz?
Yes, sir.
So what is the answer?
Heat rejection at higher temperature, sir.
Okay. So the correct answer is heat rejected at high temperature, because we know. So this is the basic schematic. So this is T1, this is T2, and T1 is greater than T2, and this is heat pump. Okay. So the heat pump, this heat is having importance because our main objective is to maintain this temperature T1. Okay. So we will draw heat from T2 and will sink that heat to T1 side. So basically the heat rejected at higher temperature is our main concern. So that is the desired effect in heat pump, and COP will be of a reversible heat pump will be T1 upon T1 minus T2 COP for heat pump. The size of a heat pump depends on, I think we have covered this question already. So the correct answer is D. Air volume and air change requirement, air charge requirement, cooling load, heating requirement. In a winter heat pump, what can be the use of the chilled air? So in a winter heat pump, so in winter, suppose we are using a heat pump, so what can be the use of the chilled air that will be coming out from the heat pump? Let me know the answer with reasonings.
Can it be option C?
Option C, refrigerate products in a dairy farm. Yeah, it seems correct. Any other answer? So the point is, the question is winter heat pump, what can be the use of the chilled air? Option A, used in a water cooler. Option B, used to cool data centers, refrigerate products in a dairy farm, run a vapor absorption cycle. So we have one answer, option C. Any other answer? Anyone? Okay, Varun, can you think about other options also? Because it is not mentioned that only one option is correct.
Yeah, even I'm having a doubt even. So refrigerate products in dairy farm, why? Because it's like in a winter heat pump, heat pump can be operated as heat, desired effect as heat producing, and other side it can be a refrigerator also. So in that case, option C will be there.
Okay.
So in the same way, we can use in a water cooler. So
Okay.
it's like in a winter condition water cooler. That's what I'm thinking. It's I don't know. It's a weird thing again.
No,
So
no. Maybe.
Yeah, used to
Don't
cool
think
a
in
data.
don't think in that
Yeah.
way. Don't think in
Okay,
that
used
way
to
that
cool
in winter.
data center it can be happening. Why? Because if you're operating any organization thing, you need cooling temperatures inside where the data centers more heat will be produced. So you need to cool the systems. So used to
Mhm.
cool data center is also a viable option.
Okay.
So that is one thing.
So what are the
And
final answer?
so that's what I go
Which
with
option should I
option.
look?
I go with option B and C. C.
Option B and C, and you are saying option A is wrong because you are thinking that in winter no one
No,
will
no, it's
drink
not
cool
in the.
water.
It's not in the. It's like with the concept wise, we can cool the water also.
Yeah. So only go through the concept. Don't think that in like in no one will
Nothing like
drink
that. Yeah,
cool
it's
water. Yeah.
then it's go with ABC. Then it should be ABC then.
Okay. Yeah. So as whenever you like, this is just advice. Whenever you are solving a question, just go with concept. Okay. So
Sure,
let's see.
sure.
So the correct answer are A, B, and C.
B and
So
C.
water cooler is also correct because maybe someone likes cold water in winter also. Okay.
Yes, yes. I'm stuck with that run. I'm just circling with a vapor absorption cycle. How it will be happening again. So there
Uh-huh.
heat source is required, but not cooling source. Vapor
Yeah.
absorption cycle, you have to give the heat source in some
Heat source.
regenerator or something.
Correct. Correct. So basically, if we are having chilled air, then this chilled air can be used in water cooler to cool the water, also in data centers, also in refrigerated products in dairy farm. Okay. So basically, there are three applications for the chilled air that can be used in water coolers, that can be used to cool data centers, that can be used to refrigerate products in dairy farm. So next question. For an air heat pump used for air round conditioning, what is the function of the four-way valve? I think we have already covered this question already. So the correct answer will be B. Reverse the functioning of evaporator and condenser. So why does a templifier unit employ a two-stage compression cycle? Yeah, what is the reason to apply a two-stage compression? We have like already covered like which type of compression, a low compression and high compression, high pressure compression, low pressure compression. So why does a templifier use these two-stage compression? What is the reason behind that? Or what are the reasons behind that? Let me know the answer.
So if I go with option A, first of all, increase refrigeration capacity. So if you're doing two-stage compression, automatically the evaporator, that refrigeration capacity increases if you just draw the curve. So you'll be getting an increase in the refrigeration capacity.
Mm-hmm.
So that's thing. And second thing, reduce the capital cost. Why? Because if you compress the air to such a high temperatures, it's like to such a high temperature lift, the compressor work will be more if you are doing without any intercooling in between.
What is the purpose of templifier? Is it doing refrigeration or it is doing like heating?
It will be doing heating.
Okay.
So it will. So if you're high, it's like reduce capital cost. So compressor, we can reduce by reducing the compressor capacity. We can reduce the capital cost. Or so I will keep that option in hold. Improve COP. Why? Because the compressor work will reduce.
Okay.
So refrigeration effect will it's like okay, compressor work will reduce first of all. So it might improve the COP and
Yeah,
handling
that
high
seems
temp.
correct. COP because if you are installing two compressor, then the capital cost will increase actually. You need more
Hmm.
maintenance, you need more space, you need everything more.
Hmm.
So capital cost,
So
it
capital
seems not
cost will
viable
increase.
option.
Yeah, so
will
in
increase for sure.
COP will automatically increase, so it will improve,
Improve COP,
and
correct?
we can handle the high temperature lift also. Why? Because in between we are doing intercooling, and again at a stage we are not increasing the temperature from lower to higher in one stage, so we can handle the high temperature lift. So if that is the case, it's option A, C, and D.
Think about option A again. Is it A correct?
Increase refrigeration capacity. No, it's okay. Actually, but the line will be shifting inside the car. It will not be, because it's as amplifier. It's heat source, heat pump. So increase heat refrigeration capacity will not be the answer.
Yeah.
That is the case.
So the correct answer will be improve COP and handle high temperature lift. So basically, for a like to high temperature lift, we are using the two-stage compression, not to increase the refrigeration effect or capacity. We are just doing it for high temperature lift. Okay, and we are employing two compressor. Then the COP will improve. It will improve the COP, and it can handle high temperature lift. That is the main objective of a templifier. So option C and D are correct, because if you are using more compressor, then automatically capital cost will increase. Option B incorrect. Option A is also incorrect. So an incineration plant can be used for a remove pollutants from gaseous waste, disposal of waste, process, heating, all of the above. Let me know the answer.
Disposal of waste.
Disposal of waste. Okay, let's see. Wait for 2 more minutes. Try to focus on this statement. It is saying an incineration plant. So plant means not only the incineration unit, it is complete plant with all system, with all balance of plant equipment. Now think about the answer.
If that is the case, then it will be all the above. Why? Because process heating also will be a part of incineration plant.
Yeah, correct. That's why I underlined that point. Because earlier you told only one answer, that it will be
Yeah,
the disposal of waste. But disposal of waste is only for incineration unit. Yeah,
incineration unit. Yeah.
incineration unit only disposal of waste. But if we are talking about the complete plant, then we are also generating heat and we are using that heat. And we are also having some system to remove the pollutants from the gaseous waste. So the correct answer will be all of the above. A, B, and C, because all these three will come under the incineration plant. In the fume incinerator, discuss in class what is the gas that is used for polyester synthesis. I think we have already covered it. It is N-butane. A heat pump using R12 is to be used for winter space heating of residence. The building heat loss is 20 kilowatt. Compression is reversible and adiabatic. Inside temperature building 25 degree. Environment is 5 degree. Determine the COP of the heat pump. Calculate. Let me know the answer. I think similar question we have already covered, but some numerical data is changed. So just recalculate and let me know the answer.
So option D, 15 COP.
Okay, option D. Okay. So let me underline the important points. Compression is reversible and adiabatic. Degree centigrade, 5 degree centigrade. So it will be 98 Kelvin. Okay. It will be 278 Kelvin. Okay. This is reversible. W. Okay. Heat pump reversible. Okay. So the COP of reversible heat pump, we know that the desired effect upon work input. So or you can say the 298 upon 298 minus 278. You will solve, you will get how much?
15. Sir.
No, I think it will be 14.9, I think. Tell me the exact answer. How much?
It's 14.9 only. Yeah.
Yeah, it's 14.9. So COP is 14.9. But there is no option for 14.9. So the most go for the nearest option. So it will be 15. So the correct option will be option D, 15. So in previous question for the heat pump, what is the work done by the compressor? So with same data, let me know the work done from the compressor. Take another 2 minutes to answer. You have COP, you have other data. So let me know the work done.
One 1.33 kilowatts.
Okay. So if you solve, then we have COP equals to desired effect upon work done. Okay. The desired effect in our previous question is 20 kilowatt. The COP is 15. So put the data like 15 equals to 20 upon work done. So work done will be 20 upon 15, 1.33. So go for the nearest option. That will be 1.5 kilowatt. So the correct answer is A, 1.5 kilowatt. So for the previous problem, if the same work is supplied, so this is the problem, okay? Now the same work is supplied to the compressor in summer where the ambient is at 40 degree and room is maintained at 25 degree. So the temperatures have been changed, okay? Both temperature have been changed. Now, but the compressor work is the same. That is 1.5 kilowatt. Now determine the rating of the unit of cooling. Determine the rating of the unit for cooling. Okay. For the previous conditions, will be 25 and 5. Any answer? The work is same, that is
30 kilowatt.
30 kilowatt. Okay. What is the desired effect?
It's cooling.
Cooling. It's 25 degree. So you have to recalculate the COP because the temperatures have been changed. The COP will be desired effect 25. So convert it to Kelvin. How much?
19.86. It's 298 by
298 upon
40 by
difference of temperature. So 40
Yeah.
minus 25. How much? You should always write in Kelvin
19.86.
actually. But if you should write in temperature in Kelvin, but the temperature difference remains same in Kelvin and degree. So that's why I'm just writing in degree centigrade. So COP is coming about how much?
19.86.
19.86. Okay. Now you have given the work done. So you have to determine rating of cooling. So COP desired effect upon work done. So the effect will be COP into work done. COP into work done. So 1.5 into 19.86. How much?
30 kilowatts, sir.
Let me know the exact answer. 1.5 and 19.86.
29.79.
29.79.
79. Yeah.
So the nearest possible option, check the options 20, 25, 30, 15. So 30 kilowatt is the nearest possible option. So the correct answer will be option C, 30 kilowatt. Now for question 10, what would be the COP for cooling? I think we have already calculated the COP. Just let me know the answer.
19.86.
So COP, as if we have already calculated, that is 19.86. Yeah. So see the nearest possible option, that is 20B. So the correct option will be option B. The COP of the cooling will be 20. Okay, so these are the questions for today. Now let's revise some basic concept. Still we have some time. So this is a basic schematic of heat pump system. Okay, T1, T2, the temperature, required temperature, you can say higher temperature, T2 lower temperature. They are providing some work. Okay. E is the evaporator, C dash compressor, and C is condenser, and EV is expansion valve. So this is the complete process. Okay. So the COP of heat pump is desired effect is Q1, and W is the work done to the compressor. So we have already, I think we have covered 3 to 4 numericals based on this very important formula for COP. And also COP of heat pump is always greater than 1, and it will be 1 plus COP of refrigerator. Okay. So what are the value proposition for heat pump? So heat pump used for upgradation of low grade or rejected heat. Example, low grade heat at 35 degree can be upgraded to deliver heat at 80 degree. So it used for the increase the quality of energy at the cost of external work to compressor. Mostly used when both heating and cooling are required. Example, year-round conditioning. So we mostly use this for heating and cooling. Capital cost not different compared to AC system with electric heaters, but energy cost is lower. Like suppose we are having an alternate current system, or you can say an electric heater, or you can say air conditioning system with electric heaters. No, I think it's alternate current. Capital cost not different to the AC system with electric heaters. Okay, no, it's air conditioning with heaters. There are some air conditioning also there with some electric heater system for the supplying of heat. But the capital cost is not different, but energy cost. Okay, the consumption cost will be lower. The heat pump capacity and working fluid, so determined by the cooling load in the evaporator. Like what will be the capacity of heat pump? We have also covered one question about it. So it will be the cooling load in the evaporator, air volume and air charge requirement, heating load on the condenser, and capital cost. Working fluid, namely, mainly we use R1, R12, R21, R22, R114, and azeotropic mixtures R31, R114, R12, R31. These are the main working fluid. So what are the application of heat pump? So cooling and heating required at two different places in a process. So we can use that. Suppose we require here hot product, okay, and so the cooling and heating at two different places in a process. Two process streams. One needs heating and another need cooling. Here we can see the hot feed is coming, and chill feed is coming. So in this way, the heat pump can be used. So the year-round air conditioning, so air heat pump is there that can be used for cooling during summer and heating during winter. Ideal for residential and small enterprises. I think a four-way wall question was also there. Okay, that can be used for a heat pump to interchange the evaporator and condenser, so that we can get cooling during summer and heating during winter. So this is a schematic of a swimming pool heating system. Okay, so this is the evaporator, this compressor, then condenser, then from here we are supplying treated water to the swimming pool. Okay, and the rejected water is going to the, like, this is, you can say, the cold water. Okay, after rejecting heat, This is the heated water that is going to swimming pool to maintain the temperature. And same concept, evaporator and condenser we are using. Okay. So Westinghouse Templify heat pump unit recovers heat from wastewater for reuse in heating process like steam generation or space heating. Use two-stage compression. So it recovers heat from wastewater for use in heating process, okay, like steam generation and space heating. So what is the main purpose of templifier? It is for heating process like steam generation and space heating and use two-stage compressions. So this is the templifier heat pump. You can see high HP pump, high pressure pump and low pressure pump, okay. Evaporator, condenser. So this is the example of heat pump drying for timber. I think we have already covered a question about it also. So evaporator drops humid air temperature below dew point. So this is the dehumidifier, you can say, or evaporator. So this is humid air coming from here. So it will decrease the temperature below dew point so that the water will condense and the air going will be totally dry without any moisture. Then with this fan, we are increasing the speed of the air, or you can say the forced convection. That air is going towards the stack of timber. So now the dry air will come. The air will trap the moisture from the timber and again will become the humid. And again, this humid air will go to the dehumidifier where again the moisture will be trapped. Okay. The water vapor condenses and drains off. Cooled dry air is next passed through the condenser to elevate its temperature, and hot dry air from the condenser is used for drying. In this way, we can dry a stack of timber. Energy storage systems. So we have an electricity utility system. So we have variable demand, hourly and even seasons to seasons, but fixed supply. So result, large expensive plant mostly operating low capacity. So that's why, because the demand is variable, but we have a fixed supply system. So it will, because so large expensive plant mostly operating below capacity. Like we can generate more power, but we are not generating, we are not working on, or we are not working on that power, then it will be not cost effective. Okay. So what we will do, we will apply the energy storage system. We will store the excess generated energy. So it will meet the fluctuation of in electricity demand and assure a steady supply economically. So suddenly if demand is increased, then we can use that stored energy system. So plant is continuously operated in base load mode. So if demand is less than capacity, then what will we do? We'll store the excess energy using mechanical storage systems, like we have I think we have covered compressed air storage system, okay, and hydro pumps, like hydro energy storage systems. If demand is greater than capacity, then what we will do, we will use the stored energy is released, we will release the stored energy. In this way our plant will operate in base load mode. We will get maximum efficiency and also it will cover the throughout demand. So this diagram is showing the energy demand fluctuation. Okay, you can see early morning the demand is very low. As the 6 p.m. to 10 p.m. demand is increasing. After that, it's like quite similar. In the night time up to 8 or you can say up to 9, the demand is again increasing, then it's again decreasing. Okay, so in this way, the demand pattern is similar like this. Okay, you can say we have less demand, then again high demand, then again low demand. So in this section, where demand is low, we will store energy in the mechanical energy storage systems or some other energy storage systems, whatever you can afford. And at this time, when there's a peak demand, we will use the stored energy. So we are having some systems for electric energy storage like mechanical, electrochemical energy storage system, magnetic, thermal, and chemical. So we are having different type of energy storage systems. Mechanical energy storage, electrochemical energy storage, magnetic energy storage, thermal energy storage, and chemical energy storage. So the mechanical energy storage systems cover the pumped hydroelectric storage, it's PHS, then compressed air energy storage, CAES, and flywheels. So basically in pumped hydroelectric system, let's see. Yeah. So in this pumped hydro storage, what we will do? We will pump the water at lower potential energy to higher potential energy. Okay. And when the demand is more, we will again use this high potential energy to run the turbine. So water pumped into a high reservoir during off-peak hours. During high demand, water flows down and power the reservoir turbines. It is used for load balancing of energy. So advantages are it's mature and reliable technology. Hundreds of plants around the world. United States has 19.5 gigawatt of capacity to 4.5% of base load. It is having high overall efficiency, 70 to 80%, and faster response time. But it also has some disadvantages like limited potential sites, need for high altitude reservoir, and environmental and political factors. So these are the like installation. These are increasing with the years. Okay, the very early 90s, this late 90s and early 20s. You can see they are how they are increasing. So in India also we are having some installation. These are the states: Andhra Pradesh, Maharashtra, Tamil Nadu, Gujarat, Jharkhand, Madhya Pradesh, Maharashtra, Gujarat, West Bengal, Maharashtra, Uttarakhand. Okay. So latest one is here Uttarakhand, 2018. I think it's already completed because this data is for 2013. Okay. So example of San Luis, California. So each of the 8 pumping generating units has a capacity of 63,000 horsepower as a motor and 53,000 kilowatts as generator as a pumping station to fill San Luis Reservoir. Each unit lifts 1375 cubic feet per second at 290 feet total head. As a generating plant, each unit passes 1640 cubic feet per second at the same head. So this is the example of this energy storage system. Okay. Another example is Brunchen Reservoir and Loch Awe, Scotland. To drive the turbine generating the electricity to this generator. So basically, off peak, excess electrical energy drives an air compressor. Compressed air stored in underground reservoirs, aquifers, or caverns. Then compressed air used to drive an air turbine coupled to a generator and delivers electricity. So what are the pros and cons? So advantages are high storage capacity, similar to pumped hydro, high overall efficiency, in the range of 70 to 80%. Then faster response time is also inexpensive. What are disadvantages? Like require large storage reservoirs, storage limited to a day for adiabatic system, not matured yet, and competing against other storage needs. Type of compressed air storage, like adiabatic storage, heat from the compression is captured and stored in a solid or liquid like peg pad, hot oil, and molten salt. Heat is reincorporated during release and close to 100% efficiency. In the diabetic storage, heat is lost through cooling. Natural gas is burned to reheat compressed air. It is inefficient and use half gas of an all gas plant. So this is the one installation like in Germany. It was of 290 megawatt, 1978, world's first compressed air energy storage plant. Two mine salt caverns with total volume of 300,000 meter cube at a depth of 600 meter. Hybrid variety, heat addition prior to GTs using natural gas as a fuel, and storage occurs daily for 8 hours at the rate 60 megawatt and generation for 2 hours at the 290 megawatt. It uses like we are storing the energy for 8 hours, okay, at the rate of 60 megawatt, because these 8 hours having low demand and we are generating for 2 hours only, because these are peak demand and at the rate of 290 megawatt. Uses 0.8 kWh for electricity and 1.6 kWh of gas to produce 1 kWh of electricity. So it is using 0.8 kWh of electricity and 1.6 kWh of gas to produce 1 kilowatt hour of electricity. So this is also an example of Alabama, McIntosh, Alabama, 110 megawatt. So stored compressed air up to 7.5 megapascal in an underground cavern. Okay, 40 meter below surface. Storage capacity is 500,000 meter cube. Generating capacity of 110 megawatt over 26 hours. Natural gas heats air before expansion in turbine. Recuperator, we use heat energy from the gas turbine. It uses 0.69 kW of electricity and 1.17 kW of gas to produce 1 kilowatt hour of electricity. 25% less compared to kind of CS plant. So it is more. Okay. So several others commissioned or under development. Okay. Okay, I think these are not covered yet. Sabah's flywheels have covered or not?
Sir, covered, sir, flywheel also.
Flywheels have also covered? Okay.
Yes, sir.
So actually it comes under week 10, I think so.
Yeah, not in this week 9. Yeah.
Yeah. So till the energy storage systems of till the hydrogen storage, pumped hydro storage, till that it is covered.
Okay. Yeah, that's why I was thinking that it's not covered. Yeah. Okay, I think we have covered enough. So let me again open the numericals and go through them, because we still have, I think, around 20 minutes. So if you want to discuss anything, floor is open.
Greater than 1, sir.
Okay, yeah. So COP of heat pump is 1 plus 0 refrigerator. Size of pump, I think we have already covered it.
Hello, Mr. Amit. I'm really sorry. Just I want to just quit the class now, have some work. So
Yeah,
I
yeah,
think the main portion is completed, right? By this
yeah,
time.
yeah, 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 yeah,
Okay, okay. Okay, just sorry for the interruption. Okay. Thank you for this session.
yeah. Thank you, thank you, thank you.
Thank you. Yeah.
So size of the heat pump is, we have like it depend on A, B, and C, air volume and air charge requirement, cooling load, and heating requirement. Fixed amplifier. So correct answer is amplifier is water type of heat pump and uses two compressors at that low pressure and high pressure compressor for its operation. And for an air heat pump used for air conditioning, what is the function of four-way valve? So basically, the four-way valve is used for reverse the functioning of evaporator and condenser. So four-way switch changes the route of the refrigerant so that indoor heat exchanger function as evaporator in summer and condenser in winter for the refrigeration cycle. Like similarly, the outdoor heat exchanger becomes the condenser in summer and evaporator in winter. For drying application, the most warm air is passed through the evaporator to reduce the temperature of warm air and to condense the water vapor and remove it from most air. So correct options are A and B. Like evaporator decreases the temperature of the air below dew point to condense the water vapor, which is further removed from the moist air to make the air dry. So incinerator are categorized according to state of the waste that is being incinerated, like solid, liquid, or gaseous. In the fume incinerator, discuss in class what is the type of gas that is used for polyester synthesis, that is N-butane. So the COP of given condition, we have given the heat loss is 25 kilowatt. The temperature limits are 30 degree, the inside temperature, and ambient is 15 degree. So apply formula. COP is desired effect upon work input or desired temperature upon temperature difference. So T2 upon T2 minus T1, it will come around 20.2. So the correct option is D. Now we have calculated the COP. Now work done will be COP is equals to desired effect on work done. So 25 upon 20.2 equals to 1.237 kilowatt. Now which of the following is a type of mechanical storage? So pumped hydroelectric and compressed air energy storage. So what is the desired effect in a heat pump system? So it rejected heat rejected higher temperature. Now size of the heat pump depends on the air volume and air charge requirement, cooling load, and heating requirement. So in a winter heat pump, what can be the use of chilled air? Can be used in a water cooler, used to cool data centers and refrigerate products in dairy farm. For an air heat pump used for year-round air conditioning, what is the function of the four-way valve? We have already covered it. It reverses the functioning of evaporator and condenser. What does a amplifier unit employ? A two-stage compression cycle. So basically, it improves COP and handle high temperature lift. So an incineration plant can be used for remove pollutants from gaseous waste, disposal of waste, and the process heating. In the fume incinerator, discussed in class, what is the gas that is used for polysynthesis? The gas is used is N-butane. So again, numerical, a heat pump is used to winter space heating for residents. The building heat was 20 kilowatt. The compression is reversible and adiabatic. Inside temperature of building is 25 degrees centigrade. Environment at 5 degree. So COP of heat pump will be desired effect upon work input, 298 upon 298 point minus 278, it comes to 15. So calculate the work done. So COP is equal to desired effect upon work done. 15 equals to 20 upon work done. So work done will be 1.33. Nearest option will be 1.5. Now again for the same, calculate the rating of the unit of cooling, unit for cooling. So again COP will be desired effect upon work done. So in this way you can calculate the desired effect will be by the multiplying the COP with the work done. So it will be 1.5 multiplied by 19.86. It will be 29.79. So the nearest option will be 30 kilowatt. COP we have already calculated, that is 20. So these are the questions for today. If you have any doubt, let me know. We are having still 10 minutes left. So the floor is open. If anyone is having any doubt, I am here, let me know. Any doubts, Abbas?
Sir, no doubt, sir.
Okay. Abbas, you are in MTech now, I think. I forget actually.
Sir?
You are doing MTech or early PhD, I think. PhD first year, I think.
Yes, sir. PhD first year, sir.
Yeah. Okay, PhD first year. Okay, nice. So how's the course going?
Sir, it is going fine, sir.
Okay. So Sabaz, maybe we have 10 minutes, so you can discuss like what is your takeaway from this course? What are the takeaways from this course for you?
Sir, this subject includes everything, sir. Subjects like thermodynamics, power plant engineering, and in some part of heat transfer. Every basics of thermal engineering it's included, sir. Here.
Yeah, nice. So because now because from I
This,
think past 2-3 weeks only few students are joining. Maybe we can hear from you that what are the benefits for joining the live session. Maybe you can share those also.
yes, sir. It is a recalling of all the subjects at a time, sir. And some part
Yeah.
of today, some part of refrigeration and air conditioning is there. No air conditioning. Only refrigeration is included till now.
And I think we are also covering some assignment questions, so those are also beneficial for the students to solve the like current assignment question. Are these what do you think, Shehbaz? How these live sessions are helping you?
Yes, sir. Good for thinking, recalling, and everything, sir. And going
Okay.
depth in subjects also.
Are you having any
Like,
benefit in your current assignment with the based on these assignment questions?
yes, sir. Some
Okay.
questions are some practical concepts also is there. What the what's going on in power plant is also is there, sir. Bottoming cycle, the top bottoming cycle, combining of Rankine cycle and
Mm-hmm. Nice. Anything else? Do you want to share with the class?
no, sir. Still nothing, sir.
Okay. this is the information for all students. Like we are having live session every week on Friday from 7 to 9 p.m. So I hope, because from last 2 weeks only few students are joining. So I request those viewing this session, those taking this session online. So I request those students to please join on the live session, because in live sessions we are having some discussion on the question also. So these are going to be very helpful for you, because if we are having some discussion, so on the discussion there will be various types of concept and doubts. So it's a good thing to discuss assignment question, and this will be very beneficial to you in your current assignments and in your exams also. So I hope these classes are helping you, and I hope in next class I will see more students in my class. Okay. So I think we have covered enough for today's class. So the recording of this class and this PPT will be shared to you with the NPT from the NPTEL team.